Hello and welcome to the C++ Insights YouTube channel. I'm Andreas Fertig. I work as a C++ trainer offering classes worldwide, on-site or remote. This is my YouTube channel where I use my tool C++ Insights to teach you various topics related to C++. Hello and welcome. Today I'm going to show you why you should never call a virtual member function in a constructor. So the code I have for that is that I have a base class fruit here, and there is my virtual member function called print. You can see it here in line number 12. Print is virtual and does the output base. And I also took care of having a virtual destructor here, which calls print again. So again, a call to a virtual member function. And then I have my derived class apple here, which derives from fruit, initializes fruit properly here, and it overrides the destructor and the print function. We can drop the virtual here, sorry about that. So here we go. All it does is it prints out apple instead of base, and below here I'm creating such an object. If we first check what Compiler Explorer has to say about that, so here we go, and we want execution, and we don't care about that. And I'm making the font size even larger. So what we can see here is that the first print here occurring in the constructor of fruit prints base. Then we have a second call to print that's presumably the destructor in apple here. So let's verify that for a moment. And here we go. So you can see the destructor in apple, that one prints apple properly as we expected. But the question then is, why are we calling a virtual member function in the destructor? So what we expect here, potentially that derived class is being called, but that one isn't. The same as for the constructor. So the first call to print here is base. I also uncomment that one, just that you can observe it yourself. So the first base is gone now. That way I hope we establish that if you're calling a virtual member function in a constructor or destructor, things behave differently than you might naively think or expect. You can see it as whenever you're calling a virtual member function in a constructor or destructor, the virtual calling mechanism is disabled. So you're always calling the member function in the class you're placing the call. So we can see it here, fruit here, that one always executes the print in fruit, while an apple always executes the call to print for apple. All right, what I'm going to do today is to show you why and how things work behind the scenes, okay? So we are going back to C++ Insights. And for today's episode, I've turned on the Show C++ to C transformation because that helps us visualize that. The C++ standard itself, well, doesn't matter here. I didn't use anything particular from newer standards. So C++ 20 is turned on by default, but that's fine. So if I do the transformation, simply can tell you to watch the episode I've done a while ago where I introduced the C++ to C transformation, because now there is a lot of information going on that's not 100% required for today's episode. Just a brief walkthrough about what we are going to need. We have this VTBL array, so the vtable array. That's an array of this struct here that stores two shorts and the vtable pointer. So that one is the crucial one for today. So it's a type def to function returning an int and taking no arguments. But that's just the proxy for having a function pointer. All right. Now, if you look at the transformation of the class fruit itself, then because we're boiling it down to C, it becomes simply a struct with a single member here because I have no data members written myself. This is the so-called vtable pointer. So you can see it's of this type mptr, and it's called table pointer fruit here. So I obviously made that name up in C++ in sites. It has to be unique, so that's an easy way to make it use the class name. Then we have the constructor here, which translates to a function that I call constructor fruit. You can see here the implicit first argument, the dis pointer that gets passed. And the dis pointer then is used to initialize the vtable of fruit. It initializes this vtable fruit pointer by using a global array vtable array. So this is the forward declaration you saw previously. And now let me scroll down. And here you can see this vtable array consists of two entries, the vtable of fruit and the vtable for apple. And here are two entries. So this is an array of vtable or mptr entries. The two shorts here, d and I, are currently always 0. They are there in cfront for reasons that are not interested in today. And then we can see, so the first entry here is the destructor of fruit, and the second one is the print function of fruit, while apple comes with the destructor for apple and print for apple. If you go back up, the vtable array at position 0 means it initializes this vtable that it points to the destructor of fruit and the print function fruit. Now here, this really ugly thing in line 29, that one places the call to the print function. Okay, this is your virtual function call dispatching. Going through the dis pointer via the vtable, picking index 1, we know, or the compiler knows, that this is where the print member function is stored. Grab the function pointer, cast it to what's required here. In C style, of course, you shouldn't do that at home if you're writing C++, needless to say. And then the implicit first argument, the dis pointer, gets casted and passed to the function. And in the destructor, you can see the same thing, but in reverse order, basically. The vtable array here is restored to the one of fruit. And then my print member function is getting called again. So this is setting it up, calling the print function. This is resetting it to apple's vtable and calling the print function. Now the vtable, or the struct apple here, looks similar. It has a vtable pointer of fruit, so of its base class type, it doesn't have any own virtual member functions. Then we have the constructor of apple here. That one reaches for the constructor of fruit. So this is where the vtable gets initialized the first time. So once the constructor was called, the vtable pointer here gets reset to the entry at position 1 in the vtable array. So that's where the apple destructor and the apple print is stored. And then you can see here the destructor once again also then calls the print member function of its own vtable at this point. Since I haven't placed a call to print here in the constructor of apple, we are not seeing anything here. If you go back to fruit, so you can see here, and this is the crucial part, the vtable gets set to the vtable that fruit knows. So this is what's always true for fruit, because fruit doesn't know whether oranges or apples derive from it. So it only knows the vtable of fruit. And then all it can do is call the member function that's stored in that vtable. And this is always fruit's own vtable. When we are going back, this is why the destructor here resets the vtable and then calls its own member function again. So I hope this gives you a better glimpse into why calling a virtual member function from a constructor or a destructor usually doesn't yield the result you want, because if the member function is virtual, you mostly expect that you have the virtual dispatching mechanism on and that the derived classes virtual member function gets called. But that's not the case, and I hope C++ Insights here with this transformation can you help understand it a little better and maybe play around with it yourself and see all the other corner cases, edge cases. Have a great C++ code writing day today. That's it for today. Thanks for watching.